today we will be starting our chapter wave optics. Here we will be studying various visual phenomena like interference, diffraction, polarization, and all these phenomena we will be explaining it with the help of wave nature of light. Okay. In this chapter, we will see light as a wave. Okay. Instead of using the particle nature of light, we will be using the wave nature of light. Okay. So first, we will understand. We will just recall all the things, all the quantities which is related to wave. So this is how any wave looks like. Right. And in class 11, we have studied about this very much in detail. So these points are called crest, where the displacement is maximum here, and this point is called drop, where the displacement is minimum here. Okay, and we have this relation talking about y equals to a sine omega t minus kx. This is the equation of any progressive wave. As you can see here, this is not progressive wave. It's moving in this direction, okay, in a positive x direction, and he is having an amplitude of capital A. Okay, where omega is my angular frequency, which is nothing but twice by mu. Twice by mu. This is my angular frequency. And K is my wave number, which is nothing but twice pi by lambda wave number. Right. This nu is the frequency of this wave. Right. And lambda is the wavelength of this wave. Right. Just a recall of the things which is related to wave. Right. So now we are going to use a certain example to understand physical quantity. Okay, and that quantity is wavefront. Okay, and that wavefront is actually going to help us to understand how light propagates. See, we have explained the propagation of light using corpuscular theory. Now we are going to understand or explain the propagation of light using wave theory. Okay. So consider a pond of still water where there is no movement of water present in that. But if we throw a stone somewhere here, okay, if we throw a stone in this pond, then what we will see, we are going to observe certain ripples of water. Okay. Now these ripples are nothing but alternate crest and drop, which begins to spread out from the point of impact. Let's say that this is any surface of water, okay, and if we throw a stone here, then we are going to observe certain wave generated by in this water, and this wave is actually going to spread out in all the directions. Okay. So these waves are only ripples. These are the circular patterns. Okay, these waves actually form this circular pattern, and we are going to use this concept to understand how light propagates from in all directions from the point of source. Okay, so let's just understand that how these circles have been formed. Okay, so what I'm going to do, I'm going to draw here. Let's say that this is where I have thrown my stone, okay, in the still water. So what it will do, it is going to generate a certain wave there. Okay, as you can see here. So this is one wave generated in this direction. You will have another wave in this direction. Okay. You will have another wave in this direction. Okay. So remember one thing, when we talk about wave, how we observe wave. A wave is something like this, where this is crest, our maximum displacement, and this is trough, our minimum displacement. So if you observe this diagram, this points, okay, this point, this is our maximum displacement. If I draw another wave here, okay, so this is again a maximum displacement, right? If I draw another wave here, uh, so again you will have another maximum displacement point. That means these are all your crest points. And if you join all this crest, you will see a circle there. Okay, so this circle I have made by joining all this crest point of different waves. Okay, now if I consider this point, this is my trough. Okay, our minimum displacement. This is the trough for this particular wave. This is the trough for this wave. Okay, uh, then this is the trough. Okay, this wave is moving in this direction, so this is another trough. So if I do that, these are my crests. So I have written it C here. This is my crest, and this is my trough. So trough. Okay, this is again another trough. So when I joined all these trough points, so I get another circle, and this circle has been formed by joining all these trough points of different waves generated by from this point of impact. Again, if I consider this point, this is another again it is a crest. Okay, you can say this is my second crest. This is the second crest for this wave. This is the second crest for this wave. This is the second crest for this wave. This is the second crest of this wave. So when I join all these waves, all these crests of different waves, I get another circle. This is my third circle. Okay, so this is how ripples of water is formed when we throw stone in a still water. Okay, so this concept we are going to use to understand how waves are formed. Okay, when actually light is moving, in any particular direction. So let's say that this is any source where from which light is emitting out. Okay, this is the point of light source, and from this point, light is coming out in all the direction. Okay, so till now we have studied that if this is my point of light source, so light comes out in this direction. Okay, we represent it by certain rays there, but here we are not going to use this part. We are going to use the wave nature of light. Okay, so if this is the source where from which light is actually going to come, so it is going to emit light in all the directions. That means we are going to have light waves in all the directions. These are your light waves. Consider this that these are your light waves. Okay, so if I consider this wave, this is one light wave which is emitting in this direction. This is our second light wave which is emitting in this direction. This is our third light wave emitting in this direction. Similarly, this is the fourth light wave and this is the fifth light wave. So if I consider this point, so this will be the crest of this first crest of this light wave emitting in this direction. This is the crest of the second wave crest. Okay, these points are all the crests or different light waves emitting in all the different directions. And when I joined all these points, all these crest points, we get a circle. Okay, and this circle is known as wavefront. Alright, so this is our first wavefront, and this wavefront has been formed by joining all the crest points of the light waves emitted in all the different directions from this point source. Alright. Similarly, if I consider this point, these are your minimum displacement points, and these are nothing but your trough points. And when you join all these trough points, you get another circle. Okay, so this is also a wavefront, our second wavefront. And this circle, it has been formed by joining all these crest points. Okay, second crest of different light waves, and this circle is called again a wavefront. Okay, so wavefront is a very important term in wave optics. Okay, so how we are going to define it? It is nothing but continuous locus of all such particles, continuous locus of all such particles of the medium which are vibrating in the same phase at any instant. Okay, so it is nothing but locus of all points which are vibrating in same phase. Okay, so if I explain it, how this locus term is coming and how this phase term is coming. So let's just understand a wave. This is the diagram of wave, right? Okay. So we are having different phase values at different points. This point is having phase 0, and this point is having phase twice pi. Alright. This point is having phase pi. This point is having phase pi by 2. Okay, and this point is having phase 3 pi by 2. Alright. So I have considered only this extreme points. Okay. And at this extreme points, this point, we are having this phase values. Alright. So when we talk about this first crest, okay, or this point is the first crest, this 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 is the first crest. Okay. So all these points is having a phase of 90 degrees, our first crest. So all these points are vibrating in the same phase. Alright, and this is nothing but my wavefront. So it is the locus of this points which are vibrating in this same phase, that is pi by 2. Okay. Now if we talk about this point, this is our minimum displacement. Okay, and at this point the particles are vibrating with this much phase, which is 3 pi by 2. Alright, so if I consider this point of this is our first drop of this wave, this is also our first drop of this wave. So we will be considering our first drop point, and we have joined this circle, and in this circle we are having points which are vibrating in the same phase, which is nothing but 3 pi by 2. Okay, so that is why wavefront is defined as such a manner. Okay, it is nothing but a continuous locus of all such particles. Right, a continuous locus of all such particles, which are vibrating in same phase at any instant. Okay, they are all vibrating in that same phase. All right. So that is how we define wavefront. All right. Let's just show you another example. Okay. So this is a linear line. Okay, a linear source. Okay, a linear light source, and light is actually emitting in all directions in the form of wave. All right, from this linear light source. Okay. So the light, let's say that light is emitting in this direction. This is one light wave emitting in this direction. Let's say that you are having another wave emitting in this direction. So similarly, you will have n numbers of waves, n numbers of waves, which will be emitted in all the directions. Let's just draw another wave. Okay. Right. So this point is our first press. This is also our first press. Our first press. Okay. Again, this is our first press. First press. First press. And this is our first press. This is our first drop. Minimum displacement. Our first drop. First drop. This is the first drop of this wave. First drop of this wave. First drop of this wave. And first drop. Okay. So what I'm going to do, I'm going to join all these points. I'm going to join all these points which are vibrating in this same phase. Okay. Again, if I join all these points which are vibrating in the same phase. Okay. Okay. So I have joined all these points which are vibrating in this same phase. Okay, for different waves emitting in all different directions. Right. So similarly, you will have waves in all these three directions. Okay, in all directions you are going to have. So what you are going to see the shape of this wavefront for this case. Okay. The shape of this wavefront is cylindrical, right? So this is also a wavefront, but in this case, the shape of this wavefront is cylindrical. Shape is cylindrical. See, we are discussing wavefront cylindrical. Okay. How these wavefronts are forming, those things we are discussing. But these types of wavefront is different. It depends on the shape of the source, right? When we were having a point source, okay. So for point source, we have seen that shape of the wavefront is spherical because he is going to emit wave in all the directions, and because of which the shape of this wavefront for point source it is going to be spherical, right? So here shape of wavefront is spherical, right? For point source, because it is going to uh, provide wave in all the direction in such a manner. Okay, so these are your crest points. When we join all these crest points, we are going to get our first wavefront. These are your first drops. When we joined all this minimum displacement or drops, we are going to get our second wavefront, right? So that is why you remember this point. That for point source, the shape of the wavefront is spherical. But if I consider our source of light is linear, okay, instead of using a point source, if I consider that it is linear, then shape of the wavefront is going to be similar. For example, if I consider this point, these are our first drops, minimum displacement. So if I join all these points, right? If I join all these points, okay, so this is our first minimum. Again, we will be having minimum displacement here also. So again, if we join all these points, so we are going to get our second wavefront. Okay, so this is our second wavefront. Alright, so shape of the wavefront, shape is cylindrical, shape of the wavefront is cylindrical for linear light source. Okay. Shape of wavefront is cylindrical for linear light source. Alright, so these are the two types of wavefront, okay, for different types of light source. Another point is that our third point, let's say light is coming from a very far place. Let's say light coming from infinity. Okay, so when light is coming from very infinite place. So those rays are parallel. Okay, so these are the rays of light coming from very infinite source. Okay, so what will be the shape of the wavefront for such case? So the shape of the wavefront is always plane, plane wavefront. Okay, it is going to be a plane wavefront. Alright, so this is our first wavefront. This is the second wavefront. Alright, so this is the shape of the wavefront for the source which is located somewhere at infinity. Okay, shape of wavefront is plane. Okay, so these are the three different cases we have studied. This is our first case, this is our second case, and this is our third case. Alright.